Hello. In this part, we are going to take a look at indirect memory addressing. This addressing mode utilizes the computer's ability of segment offset addressing. Okay, so I mean this one. I mean a segment, segment to offset addressing. Okay, segment to offset addressing. That's what I mean. Okay, so generally the base registers, the EBX, the EBP, or the BX and the BP, and the index registers, which include the DI and the SI. These ones are coded within square brackets for memory references. Okay, and are used for this purpose. Okay, so I'm talking about the EBX, and I'm talking about the EBP, or we can have their corresponding 16-bit registers, which include the BX and even the BP, like that. Okay, and the index registers, which include the DI and SI. Okay, and the SI. Okay, these ones are I say that they are coded within square brackets for memory references. Okay, and are used for this purpose. Okay, so indirect addressing is generally used for variables containing several elements like arrays. Starting address of the array is stored in, say, the EBX register. Okay, so let me show you something here. So for example, if we had let me use uppercases, my table. If we had my table, and then we use the times keyword, then we are going to multiply by 10. And we are multiplying what? We are multiplying word. We are multiplying words of 0, like that. Okay, so this one allocates 10 words, okay, of 2 bytes, and each is initialized to 0. Okay, like that. Okay, so from there we can as well go, what if we had move EBX, and then we use square brackets, and then we can have our my table, like that. Okay, my table, like that. And this one, the effective address of my table is loaded in EBX. Okay, so here the effective address of my table is loaded in EBX. Okay, like that. So from there, what if we had move, then square bracket EBX, and then we had 110, like that. Okay, so here my table, is now, for example, my table is now like this. So it's like doing my table. It's like having my table, and then we have at index 0, we set it to be equals to 110, like that. Okay, so this is the same. So this one is the same as this one. Okay, this one here. Okay, so for those who have ever programmed in C, you can note this one, or in other programming languages that use indexes. Almost all programming languages use indexes, and they can access elements inside that array, inside an array like this. Okay, or inside a list like this. Okay, so from there, what if we had add instruction, then our register EBX, okay, and then 2, like that. Okay, so this one is the same as having EBX, is the same as saying EBX equals to the previous EBX, and then we add 2. Okay, so we get the value in the previous EBX, okay, and then we add a 2, and then we set we set a new BX to all these operation. Okay, so from there we can now move what is in EBX right now, and then we move here. It's like moving here. We are moving 123 in this memory address, okay, of this current EBX, okay, where this current EBX is pointing to. Okay, so this one is the same as saying that my table, my underscore my table, then square bracket the next element is equals to 1, 2, 3, like that. Okay, so it's the same. Okay, it's the same. Okay, it's the same. So I think you get the concept. Okay, so that's how we do. That's how we do it. That's how we can fill. Okay, our table. That's how we can push. That's how we can push elements in our table. Okay, in our table that we created. Okay, like that. Okay, so in the next part we shall take a look at other concepts. Okay.